Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors Chapter 3 Quiz 1 Extra Practice Solutions on Rational Functions and Equations. To simplify this expression, let me make sure there's no common factors, and let me start that by actually factoring to see what the factors are. So in the numerator now, I need factors of negative 45 that add up to negative 4. So we got 1 and 45 doesn't work, 3 and 15 is no good, 5 and 9 would work if I had positive 5 and negative 9. So x plus 5, x minus 9. All right, one down, one to go. Let's do the denominator. We need factors of 54 that add up to negative 15. So 1 and 54 doesn't work, 2 and 27 doesn't work, 3 and 18. 3 and 18, well, that would work if one was negative and one was positive, but they both have to be positive because it multiplies to a positive, or they actually have to both be negative. Multiplies to a positive, adds up to a negative. So let's keep going. How about 6 and 9? Well, yeah, negative 6 and negative 9 adds up to negative 15. So we have x minus 6, x minus 9. And now these common factors of x minus 9 will cancel. So that leaves us with x plus 5 over x minus 6. To simplify this expression, since I'm multiplying, let me actually factor and cancel out whatever I can and then multiply. So in the upper left here, I can take out an x, leaving me with an x plus 5. And in the lower right, I can take out a 7. That's x plus 5 left over from that. I can cross-cancel these x plus 5s because I'm multiplying the fractions, so cross-canceling is allowed in that one situation. And then 9 and 24, those can reduce by 3. So 24 is now an 8. This 9 down here is now a 3. Multiplying the leftovers, we have x times 8, which is 8x. And 3 times 7 in the denominator gives me 21. To divide these rational expressions, let me turn this into multiplication by multiplying by the reciprocal. So same, change, flip. Keep the first fraction the same. Change this to multiplication. Flip the second fraction so that this 9x minus 36 is now the denominator of that fraction. And just like any multiplication problem here, let me go ahead and factor and cancel whatever I can before I even think about multiplying. In the upper left then, we can take out an x, leaving me with an x minus 4. In the lower right, I need or lower left actually, need factors of 14 that add up to 9. 1 and 14 doesn't work, but 2 and 7 does. So x plus 2 and x plus 7. In the upper right, we need factors of negative 35 that add up to 2. 1 and 35 is no good. 5 and 7 works if you have negative 5 and positive 7. So x minus 5 and x plus 7. And in the lower right, looks like I can factor out a 9, leaving me with an x minus 4. What cancels here? It looks like these x minus 4s can cross-cancel because I'm now multiplying. So multiplying allows you to cross-cancel. Because if you did multiply right now, they would just end up in the same fraction anyway. These x plus 7s across from each other can also cancel. And it looks like that's it. So in the numerator, I have an x times x minus 5. In the denominator, I have this 9 and an x plus 2. And that's as good as it gets. To subtract these fractions, let me first make sure I have a common denominator. Looks like I do. They both have an x squared minus 81. So let me just keep the denominator and add the numerators together, or subtract as it were. And I'm just going to write things out just so I don't make any mistakes. So 40 minus 3x, that's still up there then. And now we subtract this numerator. I have to distribute a negative to both terms of the numerator. So we have a minus 94, and minus minus is a plus 9x, so careful on that one. Combining like terms up there now, we have, let's see here, a negative 3x and a 9x. I'll just do the x's first. So that's going to be 6x. And then 40 minus 94, that's negative 54. Let's double check to see if we can factor and cancel. So in the numerator, I can take out a 6, leaving me with an x minus 9. In the denominator, these are both perfect squares, so I can square root and use my plus minus parentheses. So x plus 9 and x minus 9 in whatever order you want to write them. And then looks like these x minus 9s cancel. So that leaves me with a 6 over x plus 9. To simplify this rational expression, and add these, I need to get a common denominator. Let me first factor my denominators, and I can use those factors to put together an LCD and turn those both into that. So for the first denominator, I can take out a 3. That leaves me with an x plus 8. For the next one, looks like I can take out a 5. That leaves me with an x and a plus 8 as well. Dealing with the 3 and the 5 first, the smallest number 3 and 5 both go into is 15. So that's part of our LCD. And then we also have an x plus 8, and that covers both of these x plus 8s because they both appear at most once in a denominator. So now let me multiply each fraction by what it needs to get the LCD. For this first fraction, we've already got the x plus 8, but that 3 needs to be a 15. So I'll multiply by 5 over 5. And I'm doing 5 over 5 so that I'm actually multiplying by 1, not changing the value of anything. For the next fraction, I have the x plus 8, but I need a 15, not a 5, so let me multiply by 3 over 3. Actually multiplying those out, for this first setup now we've got a 10 times 5, or 50 in the numerator, and this is going to be 15x plus 8 in the denominator, which was the LCD that we were trying to get. For the second fraction, 4 times 3 gives me 12 upstairs, over 15x plus 8. I've got the same denominator, so let me just keep that. And let me add the 50 and the 12 in the numerator. That's going to be 62. Can I reduce this at all? I should always double check. Well, 62, it's not divisible by 3 or 5, and that was really it for interacting with the 15. So it looks like this is fully simplified. To simplify this complex fraction, we're going to first find the LCD of all these subfractions. So looking at all my sub-denominators here, I have an 8 and a 10 for numbers. What's the smallest thing that 8 and 10 both go into? So let me just take multiples of 10 until I find something. Because I could say 80, but I bet there's something smaller. So let's see here. 20 doesn't work, 30 doesn't work, 40 works. So that'll be the LCD for the number part. And then we also have an x in the denominator, so we need an x in the LCD as well. So I'm going to multiply the main fraction by the LCD over itself. So 40x over 1 over 40x over 1. This has the effect of not changing the value. I'm just multiplying by a fancy version of 1 right here. However, it is going to cancel out everything in my sub-denominators when I do this. So I have a 40x times the x over 8 up top, 40x times the 3/10 minus 40x times the 4 over x. Going through and canceling some stuff out now, 40 and 8, that can reduce to a 5 over 1. So I have 5 times x, or 5x squared, on top of the main fraction now. And down below, we have a 40 divided by 10. That's 4. 4 times x times 3 gives me a 12x right there. And for this last one, the x's cancel. So I've got 40 times 4, which is 160, and we're subtracting that. Just checking real quick. It doesn't look like there's any common factors that are going to cancel out. I could take, let me think here. I could take a 4 out of the denominator here, but that's not going to cancel out anything up in the numerator, so I'm just going to leave this the way it is. To solve this rational equation, a good step would be getting rid of all those denominators. So to do that, I'm going to multiply all my numerators by the least common denominator, the LCD. That's going to cancel out all the denominators. The LCD is going to have everything I need to cancel out each of these individually. So x squared would do it for all 3 of those. So I'm going to multiply x squared by all the numerators. So we have a 1 upstairs in the first fraction and the second fraction, and also this 4 is going to share the numerator as well. Going back through and canceling out what I can, the x squareds cancel completely in that first fraction. We have an x canceling out in the second fraction, and the x squareds completely cancel in the third fraction. Going back and cleaning this up, we have just 1 for that first fraction, minus, we have a 1x, and then that's all going to equal, we just have a 4 over there. So this is a very quick equation to solve. We can just add x over here and subtract 4 to get negative 3. Let's just go back and check, though. If I plug negative 3 into the original, you'll notice that I don't get 0 in any denominators. We always have to check this with rational equations. Since negative 3 does not make the original undefined, then that means negative 3 is a good answer, and we are finished. To solve this rational equation, I need to get rid of these denominators. So a good way to do that is figuring out the LCD and multiplying all the numerators by it. For my LCD, though, I need to have these things factored so I can tell what I'm looking at in terms of common factors. So this 1/2 is good, but this next fraction, the denominator, I can take out a 2v, leaving me with a v minus 1 downstairs. And for this fraction on the other side of the equals, I can factor a 2 out of there, leaving me with a v minus 1. So my LCD is going to have everything I need to cancel out all of the denominators. So we definitely need a 2 in the LCD. We're also going to need a v for this v right here. And we're also going to need a v minus 1 for these v minus 1s. Just 1 is enough, though. Now I'm going to multiply all these numerators by the LCD. So this 1 here gets it, so does this 1 up here, and so does this v minus 5, which I put in a parentheses to be safe. Going through and canceling things, these 2's are canceling, then the 2v, v minus 1's in that second fraction, and the 2's here, and the v minus 1's, but not the v. We got to be careful there. Going back through and cleaning things up, we have a v getting distributed to v minus 1, so that's v squared minus v. Here we just have a plus 1, that's kind of satisfying. Over here we have a v times a v minus 5, so v squared minus 5v. And let me clean this up a little bit. I was thinking of moving everything to one side, but you'll notice these v squareds are actually going to cancel out when you subtract. So really, I'm just going to add v over to the right side to get a negative 4v over there. I'll have a 1 left on the left side, and dividing very quickly gives me negative 1/4. Just checking, if I plug that back into the original equation here, or the factored version, I'm not going to get 0 in any of the denominators. So because that doesn't make the original undefined, this is our good final answer.